Disclaimer: the content presented in this video is intended for informational purposes only. Please be aware that the information provided may be subject to errors, speculation, or relevance variations. We encourage you to conduct further research and exercise your own judgment. All the sources are available in the description. Enjoy the video and stay curious. In the wake of the tragic events surrounding Ocean Gate, we've deepened our researches. This time in the construction materials. And what we found is truly shocking. Titan was the first privately owned submersible, with a claimed maximum depth of 4,000 meters, and the first completed crewed submersible with a hull constructed of titanium and carbon fiber. This was particularly intriguing. While carbon fiber is commonly utilized in high-end applications, its use in deep-sea exploration remains relatively unexplored, presenting significant challenges in design and manufacturing. To obtain the carbon composite cylinder, Ocean Gate partnered with Spencer Composites and the University of Washington's Applied Physics Laboratory. Spencer Composites, with its extreme experience in the making of carbon fiber, serve as the designer and the maker of the carbon fiber hull, while the University of Washington provided engineering services and experimental tests. Finally, the Titan's first carbon fiber hull was designed and made by Spencer Composites in a 6-week deadline. Transitioning to our investigation. According to Arnie Weissman, editor-in-chief of Travel Weekly, Rush has acquired the carbon fiber utilized in Titan from Boeing at a considerable discount. This remarkable opportunity arose because the material had exceeded its designated shelf life for aviation purposes. This troubling find raises a series of questions seeking for answers. What measures were taken to ensure the safety of using aged materials in deep-sea exploration? What potential risks are associated with using carbon fiber beyond its intended shelf life? How does the cost savings compare to the potential risks of using exceeded shelf life material in the construction of Titan's hull? To delve deeper into the matter, our investigation has uncovered the detailed process of manufacturing the carbon fiber hull used in the initial construction of the Titan, which was carried out by Spencer Composites. Let us explore the intricate details of its production process. Upon initial observation, it becomes apparent that the material used exhibits signs of low-quality carbon fiber. The shape of the carbon materials differs significantly from that of a fresh, appearing dry with an insufficient amount of resin, which acts as the binding agent for the carbon fiber material, which is essential for its structural integrity. These observations raise concerns about the overall quality and composition of the carbon fiber used in the construction process. During our investigation, we stumbled upon Ocean Gate former employee who had crucial information to share. According to him, between the years 2018 and 2019, Ocean Gate conducted multiple tests to reach its intended depth. During these trials, the original carbon fiber hull, manufactured by Spencer Composites, developed cracks. In a surprising twist, he disclosed that in 2020, Ocean Gate resorted to replacing the compromised carbon fiber hull. Later on in mid-2021, the replacement was made in consultation with NASA's expertise. With this recent discovery, a vividly painted picture emerges, providing clear evidence of the hull's short lifespan and strongly supporting what we have discussed so far regarding the materials used. The event underscores the critical role that the carbon fiber's quality and structure play in the overall durability and longevity of the hull, shedding light on potential implications for its performance in challenging conditions. As we continue our investigation, we've come across what seems to be the construction process of the carbon fiber hull replacement for Titan. Upon careful analysis, it becomes apparent that high-end technology is utilized, indicating a significant shift in the material implementation. This raises the question, Could this change in materials also impact the structural integrity of the replacement hull? Upon initial inspection, the materials might evoke thoughts of NASA's cutting-edge facilities, yet a closer investigation reveals a striking revelation. The manufacturer's signature clearly indicates the involvement of Spencer Composites. With NASA's involvement clarified, a new question arises. Could the carbon fiber used during the construction have been sourced from Boeing? The same supplier that provided carbon fiber with an exceeded shelf life for aviation. Well, it's clearly obvious as mentioned before, considering Rush's relationship with Boeing as an airline pilot and how cost-effectiveness for him as well. In the light of these intriguing events, it's worth noting that at the same year, OceanGate commenced passenger trips to the wreckage site of the Titanic, seemingly brushing aside the hull incident as if nothing ever occurred. So why this crucial information kept hidden from the public? Were there concerns about safety? Or was it an attempt to maintain OceanGate's reputation regardless the passengers' safety? It appears that corners were cut and caution was carelessly tossed aside in the development of this ill-fated craft. Such actions cast a shadow of doubt over their engineering prowess. During the sub's last dive, it imploded, throwing everything away. Repeating the previous scenario happens to the first hull, but this time with the loss of 5 passengers. This indicates their ignorance, as they don't learn from their mistakes. The use of aged carbon fiber materials and the lack of valuable testing such as ultrasound led to the sub's demise, shedding light on the indirect consequences caused by Boeing materials and NASA's insufficient consultations, as well as the design and making by Spencer Composites. The whole group of contributors failed in their mission, not just OceanGate. According to official statements, the University of Washington's Applied Physics Laboratory explicitly denied any involvement in the design, engineering, or testing of the Titan submersible. Likewise, a Boeing representative asserted that Boeing had no partnership with the Titan project and was not responsible for its design or construction. A spokesperson from NASA clarified that while they had a Space Act agreement with OceanGate, their workforce and facilities were not involved in testing and manufacturing of the Titan. Continuing our investigation, we have come across some compelling evidence that contradicts some of their previous statements. Initially, the University of Washington's claim of having no involvement was disproven, as we stumbled upon a captivating video on their YouTube channel, demonstrating an experiment, where they tested the utilization of carbon fiber hull under extreme conditions. Let's take a look together to delve deeper into this matter.
Critical milestones for Cyclops, a new submersible designed to take as many as 5 people deep beneath the ocean's surface, eventually as deep as 4,000 meters, more than 3.5 miles. At the University of Washington in Seattle, the first test of a scale model of Cyclops' new filament-wound carbon fiber hull, designed and manufactured by Spencer Composites in collaboration with OceanGate and APLUW.
We're testing a 1/3 scale model of the pressure vessel that will be used on Cyclops 2. Initially, when we launched the Cyclops program, we planned to have Cyclops 2 go to 3,000 meters, and we found through our engineering that in fact we can achieve at least 4,000 meters and maybe more. Cyclops 3 has been planned to be 6,000.
The pressure at 6,000 meters? About 8,762 pounds per square inch. By comparison, Navy submarines commonly operate at depths of 180 to 250 meters.
The pressure vessel consists of 3 parts, a cylinder and 2 hemispheres. One of the unique elements of this test will be the hemispheres. So the hemispheres are also carbon fiber, which has never been done at this size or to this depth.
The goal of this test, pressure of 6,000 pounds per square inch. Pressure is raised gradually. At the 71-minute mark, the pressure increased to 4,000 pounds per square inch. At 72 minutes, the pressure was turned up to 5,000 psi. But 3 minutes later, at a pressure of 4,285 psi, representing a depth of about 3,000 meters, the test was aborted by apparent water intrusion into one of the carbon fiber domes.
Yeah, she's open.
That is the most risky part of the test and the most difficult to analyze. Since it's never been done, there's no test data on how carbon fiber in a hemisphere will respond to the pressures.
This initial test was deemed a success at 4,000 psi, the equivalent of 2,800 meters. The carbon fiber hemispheres are now back at the manufacturer, Spencer Composites in Sacramento, for analysis ahead of additional testing down the road. Cyclops submersibles and related systems are the products of a commercial venture partnership, OceanGate and APLUW.
We couldn't have done it without that partnership. The Applied Physics Lab has been effectively our engineering partner.
The video stands as compelling evidence of their involvement with OceanGate and their active assistance in the development of the Titan submersible. With this confirmation, let's now move on to the next exciting find. Regarding Boeing's involvement, the only piece of evidence we currently have is a video featuring Arnie Weissman's testimony. Let's take a look at it together to gain further insights and clarity on Boeing's potential role in the matter.
I read you say something that Stockton Rush told you he got the carbon hull material from Boeing on deep discount because it was past the shelf life for airplane use?
And he said this was material that had originally been planned for aircraft use, but that it had passed a date that it could be used for that. But I said, isn't that a concern? He said, listen, we have partnered with NASA, we've partnered with Boeing on this, we put it in a pressure tank. It did give me pause, and frankly, if it weren't for the presence of Paul Henry, I don't know that I would have felt quite so confident.
Moving on to the final piece of the puzzle, NASA's involvement. Based on our thorough investigation, it has become evident that NASA's role in this matter is solely that of a consultant, which is further corroborated by OceanGate's employee. This alignment perfectly aligns with what they have previously stated regarding their involvement. Throughout this journey, we have come to a realization that all 4 participants played significant roles in the creation of the Titan submersible. To best summarize their contributions, we can categorize them as follows. Boeing, they served as the carbon fiber supplier. Spencer Composites, they were responsible for the design and construction of the composite hull. NASA, their involvement primarily revolved around consultation with their expertise. University of Washington, they played a crucial role in conducting experiments and performing laboratory tests. Once again, we'd like to emphasize that this investigation was fueled by curiosity and undertaken on a personal level. Throughout this journey, we encountered challenges and potential errors, but we remain steadfast in our pursuit of the truth. We truly value your thoughts and ideas on the matter, so please feel free to share them out. Additionally, we encourage you to subscribe to the channel, and please share the video with your friends. Your support is highly appreciated. Thank you for joining us on this exciting quest.